Hello, I'm Alex Handy. I'm the head of data science at Vira Health and also hold a senior research fellowship at University College London, where I work on applied AI in healthcare. Today, I'm going to be presenting on the development and evaluation of an AI chatbot for menopause information, which is work we've done at Vira Health with my co-authors, Nick Morse, Rehan Gottby, and Rebecca Love. Some context on Vira Health. So Vira Health is a digital health company that was set up about 4 years ago with the core mission of extending the healthy life expectancy of women, starting with menopause care. The reason for the focus on menopause care is that there is currently a significant care gap, particularly when looked at in the context of the challenges that women face in the workplace. So we conducted some research with Korn Ferry Institute last year, which identified that about a third of women have either quit or are considered quitting their jobs due to their experience of menopause symptoms. And so obviously this is a significant issue that we're looking to address. The product that Vira has built to help support this area is Stella, which is an end-to-end digital care pathway to support menopause symptoms. There are two main components to this care pathway. The first is a highly detailed onboarding assessment, which collects over 100 data points, collecting information from medical history, symptoms, and other background information, which is then collated with 3 proprietary algorithms that evaluates a woman's menopause stage, explores any potential alternative conditions that might be causing that symptomology, and then determines a personalized treatment plan, which critically includes access to immediate hormone therapy prescriptions. And this is available in the UK and the US. The second component is then ongoing support in behavior change plans delivered through a mobile app. These are personalized plans, personalized to the symptoms that have been identified in the onboarding assessment. And these plans are supported by a one-to-one human coach, along with detailed progress tracking and a range of other articles and resources to help in that menopause journey. So at Vira, we're using NLP in a range of areas to support that care pathway and the business. So highlighting 3 here, because this helps provide some context to the generative AI work, which we'll talk later on in the presentation. So the first area is around analytics. So specifically, an example would be some of the topic modeling work that we'll do on the coach interactions that users are having. The second area is around customer insights. So we have a detailed program of user interviews to try and better understand customer needs. We'll deploy techniques like semantic search and other exploration techniques to try and surface and package insights from those conversations. And then lastly, we actually have NLP embedded into the functionality of the app. And then this is where we're engineering features directly. So for example, semantic search in the app and content recommendations. So this then provides kind of context to when ChatGPT was publicly launched at the end of 2022. We were quick to start exploring how it could be used at Vira across the business, and wanted to explore how it might perform on the domain-specific questions. And so specifically, how well it might perform on frequently asked menopause questions. At the time, a lot of the public benchmarks were much more focused around closed form, kind of multi-choice, yes or no type questions, which aren't as relevant for the actual kind of user experience in our care pathway. And so we wanted to assess in a small study the performance of ChatGPT on 26 frequently asked questions from the North American Menopause Society website. And also provide some human clinical evaluation of those responses. So we treated the answers on the website as a gold standard truth and assessed the similarity between ChatGPT answers and those online website answers, and then conducted this manual evaluation to look at human likeness and also some safety and accuracy measures across likelihood of harm, any examples of incorrect recall, and also missing content. And we presented this at the British Menopause Society conference last year. The headline finding from this was that ChatGPT was providing some very convincing answers to these questions, very challenging to distinguish it from the human existing answers. And that also, encouragingly, there was limited examples of harmful responses. But it was clear that more research was required to look at some of the biases and other potential harms before you look at integrating this into any kind of live production or clinical setting. So this then feeds into the motivation of the custom AI menopause chatbot that we built and are presenting in detail today. So three key motivators for the study. The first is we've had evidence from how users have interacted with Vira's platform that there's a majority or a significant proportion of users who prefer to process information by having some sort of ongoing conversational format. Particularly just the static form of FAQs often isn't enough, particularly if you're trying to explore how something might be relevant to your particular context. Another critical element is in the prior study that I presented, there is no way of knowing where the information presented by GPT in that instance, where it's coming from. And particularly in our context, it's particularly important to have clinically verified sources, and ideally sources that you can reference directly. And then lastly, it's important to maintain and improve and reach a clinically defined level of performance so that any responses are clinically relevant, they're sensitive, and they're providing accurate information. So all of this then fed into an objective for the study of developing and then evaluating an AI chatbot that could provide reliable menopause information exclusively by using peer-reviewed position statements from the Menopause Society. So these position statements are clinical guidance documents. They'll include things like current recommended clinical practice based on available evidence and are used by clinicians and also other clinical stakeholders. They're typically relatively large documents, maybe 10 to 20 pages, tens of thousands of words, and so a good input to build an early version of this type of chatbot. So some of the technical details on how we designed this chatbot. So we built this around a retrieval augmented generative architecture. This is becoming an increasingly common pattern in the large language models and generative AI application space. Briefly, this is based on the idea that you can enhance performance by constraining or providing context from a set of documents that might be relevant to your particular domain. So what would happen is you would take, say, a particular query. You would then have an index of documents relevant to your domain. And then rather than just passing that particular query directly into a large language model, you would find content that is similar to that query from your trusted set of documents, design a context prompt that would include those chunks of relevant context, and put that into the large language model alongside the question. And there's good evidence that this improves performance across a range of domains. So we built on this architecture, we used these TMS position statements as our trusted documents. We selected 4 on hormone, non-therapy, osteoporosis, and genitourinary symptoms. Some additional technical details, which I'll summarize. So we built this in vanilla Python rather than using some of the frameworks like Llama Index and others that are available and more widely used now. And we made that decision partly due to availability at the time, but also to give ourselves some extra flexibility and learnings in this early prototype. For the position statements, we broadly looked to build off kind of default current best practice. We didn't do a lot of optimization here, but we tried a few different parameter settings. And so our final settings that we selected are summarized here on the right. So for the position statements, we chunked them into 512-word chunks. We embedded the text using OpenAI's ADA 002 endpoint. And we stored the documents in a vector fast index. The context prompt itself, we used top K similarity of 5, so 5 chunks selected from our trusted documents, and used OpenAI's GPT-4 model at the time, GPT-4 0125 preview. We also built a conversational interface using Gradio around this so we could do some more qualitative testing alongside the structured evaluation which I'll come to next. So for this evaluation, we wanted to design a set of open-ended questions which were based off the position statements, so that we could test that they were both using content solely from those position statements and also they're meeting the desired standards of clinical safety and effectiveness. So we designed 40 open-ended questions, and we're going to use two methods to do this. One, we actually took the whole position statements and ran them separately outside of our RAG system, separately through ChatGPT or GPT-4, and it prompted it to generate 40 open-ended questions on this topic. We then got two of our clinicians to review these questions, refine them, and finalize this body of 40 questions, which we then fed into our RAG system to generate the answers that would then be reviewed and evaluated. We then again used a blended approach of manual clinician review and an AI judge for the evaluation step itself. Specifically for the AI judge, we used a separate large language model, Claude 3.1 from Anthropic, deliberately to using OpenAI to hopefully limit some of those biases that you might get from having used an LLM in the question generation step. And we provided both the clinicians and the AI judge with effectively the same prompt, the same scoring rubric. There were 4 criteria that we evaluated responses on: faithfulness, relevance, harmfulness, and clinical correctness. And I'll get into more detail on how we define each of those in the coming slides. The responses themselves, they were independently scored by each of these 3 evaluators. They used a Likert scale, so 1 lowest, 5 highest. And they were averaged across those 3, but I'll also show in the following slides the individual scores from each of those 3 evaluators. So the first evaluation criteria is for faithfulness. So we define this as the extent to which the answer that is generated is from the context, so those 5 chunks, provided to the chatbot, with 1 being not faithful and 5 being extremely faithful. So we did see some evidence here that the responses were being successfully constrained to their context from the position statements, but in our first iteration, there was notably lower scoring from the AI judge. And from investigating this, we thought it might have actually been a limitation in its ability to interpret the prompt. So we explored an alternative method using a package called Raggers, where they have a method where they actually try and calculate identifying claims from each response, determine how many of those claims could be inferred from the selected context that's provided, and provide you a proportional score. So on this automated faithfulness score, scored very highly at 95%. And so this gave us confidence alongside the high clinician reviews that the content here was being, or the responses were being generated almost exclusively using material from the context in the position statements. The next criteria was then relevance. So this was the extent to which the answer is directly related to the given question. So you could have a situation where even though there's high faithfulness, it is using that context, perhaps the answer that ends up getting generated isn't particularly relevant to the question. And so what we saw here is much stronger alignment across our AI judge and the clinical evaluation, and also really strong evidence that the chatbot is delivering consistently relevant answers. The third criteria we then looked at evaluating was harmfulness. So this is the extent to which the answer to a question could be harmful if the advice was then used by a patient provider, with 1 being extremely harmful, 5 being not harmful. And again, we saw really strong alignment from the AI judge and the clinical evaluation. And actually potential harmfulness was almost exclusively assessed as not harmful across all these responses, with only 1 question assessed as potentially moderately harmful by 1 clinician. So this was really encouraging result, corroborates our earlier study as well, that there was a good safety level performance in these systems for this domain. And then the last criteria that we evaluated was clinical correctness. So this was the extent to which the answer to the question is correct and aligned with published clinical guidelines from medical organizations. So this wouldn't just be guidelines like the TMS statements that we use. These guidelines are provided by a range of other sources as well. So we wanted to try and capture that. 1 being not correct, 5 being completely correct. When running this evaluation, this was one where, again, there was a bit more misalignment between our AI judge and the clinician evaluation. Again, from exploring some of the AI judge responses here, we've had this potentially another limitation of the prompt potentially taking it too literally, in finding kind of any slight deviation in wording, causing it to score it slightly more towards, say, a 4 than a 5. But we saw much more evidence of consistent clinical correctness from the manual clinical evaluations themselves. So much higher average there, which gave us, again, good evidence that this RAG system is performing how we ultimately want it to be. So our conclusions from this work. So I think the first, we were able to demonstrate that we could develop an AI chatbot that could provide menopause information that is really generating its answers based on these position statements. And that in doing so, it is shown high clinical correctness and a low risk of harm in the responses it's providing. So an important basis of safety and effectiveness to build applications from. However, further research is still needed before you want to apply this in a clinical setting in particular. So specifically, we want to look at exploring new models, other guardrails, and also integrating a wider range of trusted peer-reviewed sources beyond just clinical guidelines themselves. So thank you very much for having us, allowing us to spend at the summit. I hope you enjoy the other presentations from the summit and look forward to answering any questions that you might have.
This concludes today's conference. I would like to extend my appreciation to the speakers for their comprehensive discussions on putting generative AI to work in healthcare and life science. We've seen firsthand the potential of this technology as well as the challenges, from precision oncology and drug discovery to cancer detection and improving hospital operations. We will continue tomorrow at noon Eastern Time for the third day of this 5th NLP Summit. We will talk about putting generative AI to work in finance. Enjoy the rest of your day and see you all tomorrow.